for the end of class for your attendance. All right, this sheet right here, this is actually something I created probably about 2 years ago, because after teaching this course for a couple of times, I realized how important Chapter 6 was in the whole grand scheme of the semester. Chapter 6 goes over factoring, basically, and basically the AAC method for solving quadratic equations. And I noticed that students were continuously maybe struggling a little bit in Chapter 6. So what I do at this point is I slow Chapter 6 down and just really, really get into the ins and outs of factoring, the ins and outs of solving quadratic equations, because if you do not understand the concepts that are outlined in Chapter 6, Chapter 7 is a feed chapter, meaning that whatever we learn in Chapter 6 literally feeds right into Chapter 7. So if you don't understand Chapter 6, there is no way that you're ever going to understand or be able to be successful in Chapter 7. So 6 is really crucial. I know it looks like this is a lot. I'm not going to read it to you. I just kind of want you to have it for two reasons. One, when you're at home and you're trying to solve these problems on your own and you're like, hey, what's my next step? You can kind of use this as a guide. It literally will walk you through solving every single one of these problems. And depending on what's occurring within the problem, whether you have options here, it's going to tell you what your next step is going to be. Also, on the next page, you have a quadratic equation, and it walks you through solving that quadratic equation every single step. By the end of this chapter, you should be able to do this without assistance of the paper. But at this point, this is just to get your mind going in the correct direction, so you can kind of look through that. Today, all we're going to discuss and all we're going to talk about is literally step 1. Okay, so step 1 is 6.1. It literally hyper focuses on finding a greatest common factor. So it says, ask yourself if there is a greatest common factor, also known as a GCF, between all three terms. If you answered yes, then you will need to extract the GCF before moving on to step 2. So in every case that we're dealing with today, that's what we're going to have to do. We're going to have to extract the GCF, or the greatest common factor. Now you will notice here that they don't push you straight into quadratic equations. They start you off with some constants, meaning in 1 and 2, those are kind of review material from secondary. And then in 3, 4, and 5, they get into more terms that have some coefficients with a little bit of variables and some exponents thrown in there to kind of get you used to the concept. And they don't throw you into quadratics more until the end of the assignment, okay? So the first page or two, you're going to be like, Ms. King, I know how to do this. This is review material, okay? If you understand how to do it, then make sure you're really grasping a hold of the concept of what they're asking you to do within the problem. So let's look at number 1. Number 1 says, find the GCF for the given list. So the greatest common factor between 27 and 45. We have to understand that factors, the definition of a factor, are values that are being multiplied together to produce a product. So we need values that multiply together to give us 27 and values that multiply together to give us 45. And then of those values, which one do both of those constants have in common? So 27, what are our factors of 27? 9, I agree. 3. 1, right? 1's always a factor of any value. They all share the same. 27 is a factor of 27 because 1 times 27 is 27. 3 times 9 is 27. Is there any more? No. Okay, so we have technically, I'm going to say 3 factors. We have 4 if you include 1, but we're going to talk about the 3. So we have 3, we have 9, and we have 27. Is 45 divisible by any of those values? 9. Okay, 45 is divisible by 9 because 45 divided by 9 is 5. So what is the greatest common factor between 27 and 45? 9. That's what you're looking for. You're looking for that GCF. If you don't know how to do that, there's a couple of different methods, and I can show you all of them. The first one is just to list your factors, which is kind of what we just did just now. We're going to list factors of 27. Always start with 1. And then we're going to move down in order on the left-hand side from least to greatest. You will notice that 2 is not a factor of 27, neither is 4, 5, 6, 7, or 8, so we're not going to list those. The next factor over here would be 9, 9 times 3, but 9 is already listed, and there's no need to list a factor more than once. Okay, so you've listed all factors. And then you're going to go through and figure out, is 45 divisible by these values, starting with the largest value present. So is 45 divisible by 27? No. Is 45 divisible by 9? Yes. That's the largest one. So this is going to pull out, and this is going to become your greatest common factor. That's one way to do it. Any questions on that one? Okay, the second way to do it, which is this, for some of you, you're going to be like, well, Ms. King, no. What are you doing? The second way to do it is to use what's called a prime factorization method. So prime factorization is where you take the value and you break it down and you only represent it using prime numbers. So 27, we're going to use factors. I'm going to use 3 and 9. So 3 is a prime value. The only factors of 3 are 1 times 3. 9 is considered composite because 9 has more than 2 factors. You have 1 times 9 and you have 3 times 3. So 9 technically has 3 factors. So we need to break this down. What are factors of 9? 3 and 3. So what is 27 represented in prime factorization form? 3 times 3 times 3. Okay. Questions on that first one? All right, let's do 45. Let's break 45 down. 45, what's the prime factorization of 45? Well, factors of 45 are 5 and 9, right? What's the prime form of 9? 3 and 3. So what's prime factorization of 45? 3 times 3 times 5. Now, looking at both prime factorizations, you're only looking for values that they both share. Because it has to be what? It has to be in common, greatest common factor. So what's the common factors between the prime factorization of 45 and the prime factorization of 27? 3 and 3. You'll notice here that those are the only ones that both of these prime factorizations share. And then what's 3 times 3? 3 times 3 is 9. Okay, so that's another method that you can use. Sometimes students love prime factorization method because they don't have to sit there and guess and did I list all my factors, you know, did I count for every value? It gives it to you straightforward. So either one of these methods that you want to use, I'm fine with. Both of them are going to get you back to the same answer. Okay, so let's look at 2. We have 3 constants. We have 20, we have 12, and we have 56. If you're wanting to use the first method, which is the listing the factors method, the easiest way to do that is to start with the smallest value that's present. So the smallest value in this case is 12. So what are your factors of 12? 1 and 12, right? 2 and 6, 3 and 4. Are you done? Are you done? What would be next? 4, right? And 4 is already listed. So have you listed all your factors? Yes, you've listed all your factors. So starting with the largest value, ask yourself, is 20 divisible by 12? No. Is 20 divisible by 6? Is it divisible by 4? Yes. Is 56 divisible by 4? Yes. So what's your GCF of these 3 values? 4. Okay. Does anybody want me to show this other method? Okay, that's good. Okay. All right. Just know that there's multiple ways that you can do the problem. All right, question 3, we have some variables coming into play. All the variables have the same numerical coefficient. They all have a numerical coefficient of 1, but then obviously they have different exponents. So when you're looking at these values, you're always going to look at the smallest exponent that's present, which in this case is 2. So your GCF is going to be the common variable with the lowest exponent present. And let me explain why. You have y to the 8th, which when represented in expanded form is going to look like this. Then you have y to the 9th. And then you have y to the 2nd. This is basically prime factorization representation of y to the 8th, y to the 9th, y to the 2nd. What do all 3 terms have in common? They all have 2 y's in common. So what is your GCF of y to the 8th, y to the 9th, y to the 2nd? It's just y to the 2nd. It's your variable, the common variable that's present, and the lowest exponent representation within the subgroup. Questions on that? Okay, question 4 says, find the GCF of the given list. You have x to the 17th times y to the 2nd times x to the 3rd, y to the 2nd times x to the 6th, y to the 8th. Let's look at the x's first. What is the GCF of x to the 17th, x to the 3rd, x to the 6th? X to the 3rd, I agree. Okay. Remember, it's the common variable with the lowest exponential representation. And then we have y to the 2nd, y to the 2nd, y to the 8th. Y to the 2nd. All right, you guys try 5 by yourself. You have a numerical coefficient of 98. You have a numerical coefficient of 147. You have a variable of y to the 4th, and you have a variable of y to the 3rd. I want you to find the numerical GCF and the variable GCF, both of them. Now, for those of you that don't like the prime factorization method, this is where you have to list a lot of factors because your numbers are so high. Do y'all see that? You see how high your numbers are? So this is where that other method actually is, but that's okay. Okay. So numerical, greatest common factor of your numerical coefficient is what you're looking for, and then greatest common factor of your variable. Don't give yourself a hard time if you get it wrong. This is the first one you've worked on, so we're just kind of giving you a second to see if you're understanding concepts. Okay, what'd you get for your GCF of your variable? 49. Y to the 3rd. Okay, good job. What'd you get for your numerical coefficient GCF? Okay, how many of you listed factors? Okay, that's fine. There's nothing wrong with that. Okay, so here's the method that we don't like or we just don't want to embrace at this point. Okay, here's 98 and here's 147. 98 divisible by 2 because 2 times, 49 is 98. 49 breaks down to 7 times 7. So prime factorization of 98 is going to be 2 times 7 times 7. Okay? 147, this is a number I'm not used to working with. So I just thought, hey, if this one's divisible by 7, maybe this one also will be divisible by 7. And it happened to be so. So 7 times 21, 7's prime. 21 was composite, so I went ahead and broke 21 down. Broke it down to 3 times 7. So prime factorization of 147 is 3 times 7 times 7. Notice here that the common factors that both of these share are the prime numbers 7 and 7, which when multiplied together gives you 49. Okay? You do not have to use this method. Just remember, it's an alternative to listing factors. Now, what you have to kind of play out in your head is when you have smaller numbers like 12, 20, and 56, those are numbers that you're used to working with. Those are more common numbers in a day-to-day environment. 147, not so much. If you get like a huge number, I don't know, 3,432, that's not a number that you're used to working with a lot. So you don't want to sit there and list out all factors of 3,432. You're going to be here for a while. So this is just another method for you to kind of look at, kind of try to understand the concept of when you're working with those larger numbers to help you break them down and find that common factor. Okay. So I agree. I got 49 and y to the third. Is that what you guys got? I agree. Okay. All right, let's try 6. I'm going to give you guys a second. 6 is smaller numbers, so what's going to be the easiest method here? 3, 6, and 12. Would it be better to do prime factorization method or just list your factors? List factors, and you're going to list the factors of the smallest number, which is 3, which for you is a good day because it's prime. Anybody else need to sign in? Yes. Yes. Okay, what y'all get? 3x to the 5th. Was the 3 positive? Yes. Okay. Notice here this is the first time we've had a negative representation come in play here, but notice only one value is negative, so not all 3 values are sharing the common factor of sharing that negative sign. So it should have been a positive 3 as the representation of your numerical coefficient in your GCF. All right, starting with 7. Now they actually get into, notice everything up here has been separated by commas, so individual terms. Starting in 7, they actually get into representing it with a polynomial. In this case, it's a binomial. So they give you 2 terms. They're going to start you off small. They're going to move you back to beginning algebra with distributive property. Do y'all remember distributive property? We use it all the time. Now you're totally comfortable with that. So let's look at it. We have the term 26x, and we have the term -2. What is your GCF going to be of the 2? 26x and a -2. What do those 2 terms have in common? Yeah, I mean, don't overthink it. It's 26x and a -2, right? So what do they share? The only thing they share is a 2. Notice this -2 does not have a variable, correct? So they don't share the common term of variable, so they just share that +2. Now, on question 7, they're only asking you to factor out the GCF, but I want to go a step further. When you pull this GCF out of the term 26x, what is your remainder? You have 26x and you're extracting a 2 from it. Remember that 2 in this case is being multiplied, so the opposite of that is division. So you're basically dividing 26x by a +2. What is your remainder? 13x. Okay. When you divide a -2 by a +2, what is your remainder? -1, right? And this is in parentheses. Your remainder is going to be inside of parentheses. So let's look back. In beginning algebra, they were building up to this point right here. And what they taught you is they said, hey, if we have, I'm going to use this space over here. If we have 2 times 13x minus 1, I want you to use the distributive property to remove the parentheses. And what would you have done? You would have said 2 times 13x is 26x, and 2 times a negative 1 is a negative 2. Okay, and that would have been your solution or your answer. So notice that this value that's out here in front, whether it be an integer, positive, negative, or it could also be a variable in some cases, if whatever value is out here in the front, this is your GCF representation. This is your greatest common factor of the values of the terms that are being represented inside the parentheses. Because if I distribute something to you, so for say, hey, I walk around, I give you $5, and I walk up here and I give Benjamin $5, then I distributed $5, right? And what do you two have in common? Y'all both have $5. Does that make sense? So here you're distributing the 2 to the values in the terms inside of the parentheses. So the term 26x and a negative 2 have a common factor, and that common factor is the 2, or the value located on the outside of the parentheses. So basically what you're doing is instead of distributing, what are you doing? You're reversing the process. Instead of multiplying, what are you doing? You're dividing it out.
Can you check it like that?
Yeah. Should always come back to your original polynomial. That's a great question. Should always come back to your original sign and all. Everything should come back and be exactly the same as the original. Okay. So let's look at 2. 2, we have addition occurring. It says 12y to the 7th plus 3y. What do these two values, these two terms have in common? Doing sign language. Say it. She's like 3. She's throwing it up over there. 3 what? 3y to the 2nd. Okay, this is your GCF, so this is the answer to this problem. I'm going to take it a step further. What is your remainder? 4y to the 5th. What do we do when we divide variables? Subtract exponents. So 7 minus 2 gives us the 5 that's located in the remainder. Okay, we have 3y squared. So we extracted a 3y squared. So what do we have left here in this second position? A positive 1. Remember, it always has to hold place. This is what Lindsay was just talking about. Lindsay said, hey, if I multiply this back out, is it always going to come back to my original polynomial? And the answer is yes. It's always going to come back to that original polynomial form. So notice that if you don't put this positive 1 here, then when you multiply back out, you're not going to get that 3y to the 2nd over here on the second position or the tail end. Okay, so make sure 3y squared divided by 3y squared is positive 1. Make sure that you place the 1 in there. Okay, questions on that first page? Awesome. Okay, factor out the GCF from the, I'm going to let you do 9 by yourself. That's a good one. If you can do 9, then you're obviously understanding the concept of what's occurring. Brandon, what did you get for your GCF on 9?
Negative 3x.
Okay. I agree with the 3x. Why did you go with the negative?
Well, because just because I knew it was right answer.
Do they all 3 share a negative?
No, ma'am, they all share a -3.
Okay. Look at I understand where he's going. Not on this one, Brandon, because the numerical coefficient in the first position is a positive number. Okay, I'm gonna jump ahead a little quick. When are you gonna extract a negative, even if all three values do not share a negative? When the first position, where's it at? When the first position represents a negative value. Okay. So are you gonna extract a negative on question 9?
Oh, yeah.
No, because the first position does not all three terms don't share a negative value, and the first position is not represented in a negative form. So what's your GCF going to be on 9?
3x.
3x. What's your remainder going to be? You might not have done that. I know you can do it real quick.
Yeah. 5x to the 5th plus, minus 3x plus 7.
I agree. We agree? Okay. Notice it's represented inside parentheses. Okay. Questions on 9. 10, you have fractions being represented here. It says factor out the GCF from the polynomial. We have 4 terms being displayed. All of them, notice that they all give you the same common denominator of 6, which is great because we know that when adding and subtracting fractions, we must have that common denominator present. Out of those terms, what is your GCF going to be? 1/6 x to the first. Okay. What's your remainder going to be? Ha ha ha, Bailey. What's your remainder going to be? Go for it. Yeah, you do. What's 1/6 divided by 1/6? You're smart. You need to share your knowledge. 1/6 divided by 1/6. What's 3 divided by 30? What's 3 divided by 30? 1. What's 1/6 divided by 1/6? 1. So we have 1x to the 7th, right? Because we have x to the 8, x to the first, and we'll subtract. All right, you're not getting past the next one. 5/6 divided by 1/6. I'm gonna put it right here. 5/6 divided by 1/6. What do? Keep, change, flip, right? So 5/6 times 6/1 equals 30/6. Don't tell me you can't divide 30/6. I know you can. What is it? What is it? Okay, so what's your remainder here? 5x to the, there you go. So what's your next one going to be? -7/6 divided by 1/6. -7, right? -7x to the second. And then what's 1/6 divided by 1/6? 1. So it's just going to be 1, right? Because x to the first minus x to the first gives us 1. All right, I didn't write it down. What was our remainder? X to the 7th plus 5x to the 4th minus 7x to the 2nd plus 1. I agree. Okay, now that's just your remainder. That's what's left over inside of your parentheses. Okay. All right, question 11. Factor out the GCF from the polynomial. So we have y and we have 8 as GCFs on the outside. So these are on the outside of the parentheses. These two values, which are considered remainders, notice that they're exactly the same. Not only yes, sir, Brandon.
I'm going to.
Don't answer the question. They're exactly the same. X to the 5th, x to the 5th, plus 7, plus 7. Sign has to be exactly the same, and variable with exponential representation has to be exactly the same. Okay, so you'll notice here they're building into it. You have x to the 5th plus 7 and x to the 5th plus 7 inside of parentheses. Okay, those are common between both, right? Common between both. So what is your GCF? Your GCF is what's common?
Wait, which one are we on?
11.
Oh,
Oh, wait, yeah.
what's common?
7.
Not just 7.
X plus 7.
X to the 5th
And 7.
and 7, right? They're both common in both terms. Do y'all see that? The first term is y times x to the 5th plus 7, and the second term is x times x to the 5th plus 7. What do both terms have in common? X to the 5th plus 7. Don't overthink it, okay? It's just a visual, this is just a visual problem here. So GCF in this case is x to the 5th plus 7, and then what's left over? The y and the 8, right? So this is your GCF. I'm going to take it a step further. What's your remainder? Your remainder is y plus 8. That's your remainder. Okay. Okay, looking at 12. What's your GCF in 12? Y plus 2. What's your remainder? There you go. There you go. You are getting it. Okay, 13. Put a star next to 13 for 2 reasons. Put a star next to 13, put a star next to 14. In 13, both of your terms share a negative. So that's a simple one. Both terms share a negative, so we're going to extract that negative with the GCF to represent our greatest common factor between negative 3x and negative 15. Well, our GCF is negative 3, right? What's your remainder? Your remainder is x plus 5, right? Because the negative 15 divided by negative 3 gives you a positive 5. So your GCF in this case is negative 3. Look at the difference between 13 and 14. In 13, both terms shared a negative. Visually easy to see there that we have a common factor that's going to include a negative representation. But in question 14, another situation comes into play, which is where the value or the numerical coefficient in the first position, the A position, let's just call it that, the A position is a negative representation. We don't ever want that to happen. So if we have a numerical coefficient in the A position that has a negative representation, we're going to go ahead, even if all the terms don't share a negative value, we're going to go ahead and extract a -1 in with our GCF, okay? So make yourself a note here. Make yourself a note that there's a negative representation in the A position. Just make yourself a little note over here. So we're going to extract a -1. What is the common factor between -8, a to the 5th, +8, a to the 4th, and -4, a to the 3rd? -4, a to the 3rd. I agree. Now I'm going to stop. Why did we say that our GCF was negative? The only reason we said that was because we had a negative representation in the first position. Okay? What is your remainder going to be? 2a to the second.
2a to the 2a.
Okay. One more, Matt. +1, right? Okay, so this is your greatest common factor. This is your remainder. Now let's look at your remainder. By you extracting the -1, what did you do to the remainder? You made the value in the first position into a what? Positive value. Do you see that in your remainder? Now the value in the A position is a positive value. Okay, so twofold here. We need to extract. If we have a GCF present, we always need to extract the GCF. If we have a negative representation in the A position, we also need to go ahead and extract out a negative value also. So that one's a star problem. It's a special case. Question 15 says, factor the 4-term polynomial by grouping. Factor the 4-term polynomial by grouping. Anytime you have 4 terms, you're going to factor by grouping. Notice that in your steps, so we have our steps over here, we've been working to understand the concept of 1. In step 5, let's look at step 5. it says group the first two factors together and the last two factors together using parentheses. And then step 6 says factor each set of binomials. These are the groupings you made in step 5. Step 5 is going to be groupings where 4 terms are present. So right here, make yourself a note. This is when 4 terms are present. So you will look and you'll kind of notice here, I'm going to try to put them up here together. Maybe they will fit, maybe they won't. There we go. In 15, you have 4 terms. So when you have 4 terms present, the only steps that you can do are 5, 6, and 7. We're not going to do 7 at this point. We're just going to do 5 and 6. So step 5 says group the first 2 factors together using parentheses. Group the second 2 factors together using parentheses. Now notice that when I group my second 2 factors, I'm also including the sign of the third term. Always be very aware of whatever the term is, whatever the sign is of that third term. So we're actually going to look at them as 2 different binomials. What does x to the third, what does x to the third and a positive 8x squared have in common? X squared, right? What's your remainder? X plus 8. We agree? Okay, let's look at the second one. What's here? We have a positive 8x and a positive 64. What is your GCF between 8x and 64? 8 is the 8 positive or negative? First term, look at the first value. The first value is positive, right? So is the 8 positive or negative? Positive. So we're actually going to express it here. Positive 8. What is your remainder? Okay, so let's pause for a second. We have a GCF. We have a GCF. I'm labeling here for you. This is considered a remainder. This is also considered a remainder. Remainders are identical, not only identical in display, but also identical in symbols or signs. So we have a positive x plus 8, and then we have a positive x plus 8. So how do we represent it in factorial representation? You're only going to need to represent the remainder one time. Okay? You're going to take your GCF. So you're going to take your GCF from the first grouping. You're going to pair it with the GCF from the second grouping by placing parentheses around them. So that's going to be the first set of parentheses, and then the second set of parentheses is going to be your remainder displayed one time. So factorial form is going to be x squared plus 8 times x plus 8. Okay. Now I'm going to stop. And I want every single one of you, because I know every single one of you can do this, I want you to use the FOIL method, and I want you to show your words over here on this side. I want you to use the FOIL method, and I want you to multiply this binomial by this binomial, simplified representation. I want it on the bottom of the page. Using the FOIL method, take the factors that you just found. So remember, factors are values that are multiplied together to produce a product. I want you to take these 2 values, these 2 factors, I want you to multiply them together and give me the product. You're going to use the FOIL method. Yes, Brandon.
I have x to the third plus 8x squared plus 8x plus 64.
Okay, so take that product and look at your original polynomial. Are they identical? Are they identical? Even in sign. Okay, so are your factors correct?
Yep.
Yes, your factors are correct. Your question earlier on distributed property, that's what it is. It always has to come back to the original. Also understand, when you're pulling them out, when you're extracting them. Okay, let me make a point real quick before I'll go back to it. Let me make a point real quick. Another thing you need to notice is that in our final answers, up here at the top, our GCF were always came down to that prime factorial representation. Remember when I was breaking it down? So notice here, if you're representing factors in simplified representation, just like in a fraction, then there should be no common factors between the numerator and the denominator, right? In a fraction, like 4 divided by 2. 4 over 2 is not a simplified representation because 4 and 2 both share a common factor of 2. Inside here, same theory here occurs. X squared and 8, there should be no common factor representation that can be pulled out between x squared and 8, which there's not. The only common factor is 1. Same thing here. X and 8, they share no common factors, no variable, no exponent, no numerical coefficients. So all this always needs to be, when you look at it, you need to make sure the values inside your parentheses are not sharing or cannot be reduced any further. So you're talking about the grouping, the original grouping.
Like when you get like when you 5 and 6, how you group them, and then with the partners and stuff, GCF and remainder, I don't understand that. How you got them.
Okay, my GCF came from the first binomial, x to the third and 8x squared. So the only thing that x squared and 8x to the third had in common was x squared. They both had an x squared representation. Okay, now you can go, if you want to, let's use the back of this sheet. You have x times x times x, right? X to the third. You have 8, which common prime factorization is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And you can break that down and expand it out. You'll notice that prime representation or prime factorization of x to the third and 8x squared only share what? 2 x's, right? It's the only thing they have in common. So that is your greatest common factor. So when you pull that out, so let's say, okay, these are our greatest common factors. So we're going to pull this out right here. We're going to say, hey, that's x squared. What do we have left over or what? Remaining, right? So remaining in the first one is just a x. What's remaining in the second one? 2 times 2, which is 4, times 2, which is 8. So what do we have as a remainder? X plus 8. Okay. What students sometimes will do is they'll start off using prime factorization form. And then eventually they'll begin to grasp the concept and then they'll start doing it in their head. This to me, I'm like, if you need to sit there and break it down, there's nothing wrong with being able to do that. Obviously that's not going to take you very long. The larger numbers, this is when the prime factorization method comes into play. It makes it easier for you if you understand the factor tree, because you can break those large numbers down real quick to prime factorization form and just see what they're sharing in common. Okay. So you could do that method and you could go back and do this. You could break down 8. 2 times 2 times 2 times x, right? And then this is going to be 2 times 2 times 2 times 2 times 2 times 2, I think. And then you would have 3 2's in common, and then you would have the, so yeah, you just have 3 2's in common, so you just have the 8 in common. Okay. And we're going to do this so much, I promise you, because that's just the first one. All right. So 16. First step, we recognize 4 terms are present. So if 4 terms are present, we're going to factor by grouping. We're going to place parentheses around the first 2 values. We're going to place parentheses around the third and the fourth value. Make sure you include the sign of the third value. Notice here that the value in the first position is positive in the first set of grouping. The value in the second grouping is also positive. So are we going to need to extract a -1 in this situation? No. No negative needs to be extracted. What is common between 4x and 16? 4. What's your remainder? X plus 4. Okay, what's in common between x times y and 4y? The y, is the y positive or negative? Positive, so make sure you put that plus sign in front of it to symbolize. And then what's your remainder? X plus 4. So visually looking, are our remainders identical? That's what we need to be looking at next. Are they identical? Yes, same sign, same value. So how are we going to write factorial representation? 4 plus y, GCFs come together. X plus 4. How do we check our answer? Lindsay, how do we check our answer? No. This is your question, all husband. How do you check your answers? Use your formula. Distribute it back out. Combine my terms, and what should you come back to? You should come back to the original polynomial. Okay? Yes, ma'am.
So does it matter which order you put them in or not?
It doesn't matter the order because it's associative property. Remember, associative property multiplication states it doesn't matter the order or the grouping that you place it in. You should still get the same answer. So whether you place x plus 4 in the first position as a group and 4 plus y in the second position, doesn't matter. When you multiply back out full numbers, you're going to get the same. Good question. All right, let's try to let you, I want you to work. Let's work in groups of 3. Let's work in groups of 3. And let's try to finish this up. So I want you guys to kind of problem solve, think through questions 17 all the way through 21. Now, be aware, be very aware that on question 20 and on question, it looks like maybe on question 21. Yes, when you do your grouping, so I'm just going to do it on 20 for you. When you do your grouping here, look what happens. The first set has a positive value or a positive numerical coefficient in the first position. Your second grouping has a what? A negative in the first position. So what are you going to have to do? Extract out a -1. So put you a star here. Make sure you know you need to extract a -1. Make yourself a little note. So those are the things that you need to start looking for within your grouping, okay? I'm going to give you a few minutes, 17 through 21. That's what you need to be working on in your groups. Okay, so looking here.